Hi, everybody, and welcome back to the Shifu Math Practice Lab and the Algebra 2 lecture series. And we are starting the chapter 2, and we are in the lesson 2.2. As I mentioned in the previous video, the chapter 2 is to talk about the linear function. And in the video number 1, we talk about what is the definition of the functions, right? So now in this video, we're going to talk about, we talk about the linear function. What is the definition of the linear function? And so in fact, this is a very short video, going to be a very short video because the definition is pretty easy, okay? And it's very easy sections here. Okay, so now I'm going to go to the worksheets and let's take a look, all right? So my worksheets here. Okay, so this is the worksheets we're going to work on. And so it's the linear relation, the function. How do we define a linear relation of functions here? All right. And so this is the worksheet. As always, I'm going to work the examples and was written in blue. And here, the remaining part will be the exercise for you and to do it, right? Okay, so the linear functions, okay, so this is what we talk about, is the linear relations here. Okay, so the linear relations, okay, so let's take a look here. So the linear relations here, they say, or linear functions here, that means you can write into any function, linear function can be written in the form f of x equal to mx plus b. And m and b are any real numbers, okay? We're going to go over in great details about, this form, y equal to mx plus b. But for these sections here, we're only going to talk about how is, when they give you functions, right? You want to see if this is a linear function or not. So for these lectures here, we're going to say, okay, how to identify a linear function? So the easiest way to identify a linear function is just the, you have both variables, x and y, in equations here. And then they can be any kind of a combination with some constants. The only things here is both x and y, they cannot be, for example, on the denominator. They cannot be the exponents, right? They cannot have roots, like square roots or fourth roots, anything like that. It has to be just x and y with some constants. That's why see here they said, when you see like f of x, gx, really this is the y's here. That means, so really they just tell you, say, hey, if these relations here only have y and x, only those two variables, right, is in the equation, and those two variables, just x and y, you cannot have like x to the 1/2, something like that, or you cannot have something like e to the x's here, or you cannot have like x over the denominators, right? It's just x and y. So the same things for y. You cannot have y have the square roots, exponents, or on the fractions here, right? So it's just x and y and some constants here, right? So that's how do we identify, this function is a linear function or not. Okay, so now also like I want to mention here, doesn't have to be both y and x exist, right? So if you say x equal to 2, this is a linear function, right? So because the x here is just the x and is not on the denominator or the square roots. So if you said 3y equal to 4, this is a linear function, all right? So it's because just like the y, and I don't have to have both, but the y is just by itself, is not have the square roots or the denominator, those things. Clear, all right? So now we have this ones here is easy to identify. So let's take a look at the examples we have here. So the first problem here, y equal to 3x. Is this a linear function or not? Well, let's take a look. Y is by itself nothing, and x is by itself, doesn't have exponents, it doesn't have the roots or in the denominator. So what I say here, we say yes, right? Okay, so now the second one is here. We say y equal to the -2 plus 5x. Let's take a look. Let's circle the y and the x. Do they just by itself? Yeah, they don't have any like the square roots, exponents, or in the denominator. Then with some constants, that's fine. So this is a linear function? Yes, right? Okay, how about this one? 2x plus y equal to 10. It doesn't matter which side of the equal sign, x, y. So this is x, 2x plus y. So let's just circle x and y. So you take a look, you say, oh, the x and the y just by itself, they don't have any exponents or the roots or in the fraction. So this is the linear function? Yes, all right. Okay, so let's take a look. Number 4. So remember when you see the f of x or y, so really this means the y's, right? So y equal to the 4x here. So let's take a look at this one. This is a linear function. Let's look, y is okay by itself here. Hey, what happened to here? I have a what? I have a x what? X squared. I said, oh, I cannot have that. X has to be just by itself. I cannot have x squares here. So this is a linear function? No. All right, so this is not a linear function. Okay, let's take a look at these ones here. This is -3 over x plus y equal to 15. Okay, so let's circle the x and y. Okay, so x, y here is okay. Now let's take a look at these ones here. Hey, what happened to the x here? Oh boy, this x here is what? Is on the denominator. So we say the x and the y has to be by itself, cannot be in exponents or roots, square roots, or in the denominator. So because of this x is on the denominator, so this is the linear function, we say no, this is not a linear function, right? Okay, now let's take a look at number 6. So look at the x and y. So x equal to the y plus a. So look at x and y. Okay, so they are pretty simple. They don't have exponents, they don't have square roots or some type of roots. They are not on denominator. So this is a linear function? Yes, right? It's pretty easy. Okay, so now the next ones here, we say the g of x equal to y. G of x equal to 8, right? So remember, like f of x, g of x, this is what we call is y. So, okay, so this is y equal to 8. This is a linear function? Yes, right? We say we don't have to have both. I have a y, and this y is just by itself. So it's good, right? So this is a linear function here. Okay, so I don't have to have an x here. Okay, so now the next thing is here. This is the one, h of x. So this is y here. So this is a y of the square roots plus 3. Then you see, oh, here, what happened to here? Huh. I have a what? I have a square root, right? So if you look at the x part, y is okay, y is okay. But if you look at the x part, what happened to the x part? X has a square roots. I said, no, x cannot have any of this. X has to be just by itself, right? So you can have 3 times x because x still by itself, but x cannot have exponents, cannot be inside the square roots, cannot be in the fraction. So what is the answer for this one? So this is no, right? So this is not a linear functions here. So that's it. Like I said, this video is a very easy video, and like we just identify is a function is a linear functions, right? So remember what is the what is the criteria? When you look at function, you circle the x and the y. Don't worry about the constant, right? So you circle the x and the y, and then take a look. Are those x and the y's are just simple x and the y? They don't have exponents. They are not in the exponents. They are not in the square roots. They are not in the denominator. Then we will say it is a linear, right? So like in here with 3 examples, they are not a linear function because they violate the rule. First one's here. This x is not a simple x. This is x squared. This x here is on the denominator. This x has square roots. All right. So that's it. Okay. So this is a very simple topic, and I'm very confident you will be able to do the exercise and at the end of this worksheet. Okay. All right. So nice to talk to you, and so looking forward to talk to you on our next video. It's so nice to have such short videos, right? Okay, great. And looking forward to talk to you again, and have fun in math, right? Don't forget doing the exercise, practicing, practicing, practicing. That's what to make you getting better in math. Okay, so nice to talk to you, and looking forward to talk to you again. All right, bye. Have a good day.